Hello friends, today we will discuss the diagnosis of the fault. Direct cool refrigerator doesn't cool. The compressor and light they are not operating. The customer's complaint is that there is no cooling in the refrigerator. The light inside the refrigerator doesn't glow and the food is getting spoiled. Some questions that we ask the customer are: have you checked this machine by plugging it to another socket to understand the power incoming or not? Have you checked the stabilizer? That is, have you checked it by hooking it with a stabilizer to understand whether there is any voltage fluctuation or not? So we also ask them whether there is any cooling in the freezer section, just to understand whether the compressor is running or not. We also ask if the light is glowing inside the refrigerator while we are pressing and releasing of the switch to understand the power input to the refrigerator. Any running sound in the refrigerator, compressor, etc. Any sparking sound which will indicate phase or neutral short. Some possible defects are: there is no power supply in the power socket, the stabilizer is fused, the main fuse is blown off, some problem with the power cord, or if it's an electronic model, then maybe the main PCB is defective. Here we have segregated it into electrical, electronic, mechanical kinds of failures. Let's understand each one of these defects separately. We will check all the possible defects one by one. Initially, we check the main incoming power point, that is the socket, the neutral to the left, phase to the right, phase neutral and phase earth. They would show a voltage of somewhere around 230 volts plus or minus 10 volts. The voltage between neutral and earth when the power is on should not be more than 3 volts, and the phase should be on the right, neutral on the left, and this point should have a proper earthing for the machine to work. There should be no continuity between the neutral and the earth point. In case of proper earthing, we find some voltage in between the phase earth as we found in phase neutral. If we don't get the same voltage as mentioned above, it shows that the earthing is weak. If the voltage between earth neutral is more than 2 volts, it shows that there is some leakage of electricity which will lead to failure of electronic components. The phase is on the left side of the socket, it will lead to sensation of current in the body of the product. The PCBs get damaged. So it is always advisable that the phase should be on the right side and neutral to the left. For checking the stabilizer, what we would do is we would check the output of the stabilizer from the output point. We would be requiring a multimeter and a screwdriver. This is the stabilizer as shown in this diagram. It has a transformer, it has an output socket, it has some input wires, it has a control card and a display card. There is a low voltage connection for PCB operation which comes from the transformer. There are a lot of wires with a very thin flat connector. This usually is the connection to the display, and at the top in that white connector near the 3 black relays you see the AC mains connector, that is the main input. Red is the main input and blue is the output, the socket. In the stabilizer, the operating range, the input voltage range 130 to 280, input working range 135 to 275, output voltage range is 180 volt to 250 volts, The rated capacity of the stabilizer is 390 volt ampere, 1.7 amperes at 230 volts AC, and the operating temperature of the stabilizer is usually 0 to 50 degrees Celsius. Here we have shown the electrical circuit diagram of the insides of the stabilizer. We have a transformer which has got step up, step down relays, and we have a power supply. We have got a comparator between the input and the output, and we have a switching circuit which switches the output supply of the transformer or the output winding of the transformer with respect to the input voltage. And we have a display wherein all the status of the input and the output voltage is shown. Simply, what are the transformers? Transformers are some electrical devices. They are used to convert or transform AC voltage from one level to another. That means it will step up or step down the input AC voltage. They do it with the principle of electromagnetic induction. Step down means the output voltage is less than the input voltage. Step up means the output voltage is more than the input voltage. The various parts of a transformer are the primary winding. It is an electrical wire which is wrapped around the core of or the input side. Secondary winding is an electrical wire which is wrapped around the core on the output side. The core is a ferromagnetic material that can conduct a magnetic field through it. Usually it is made of a ferritic material or a material which contains iron. This is the simple circuit diagram of a transformer with the primary winding, the iron core, and the secondary winding which is shown. The core will ensure that there is no physical continuity between the winding and the core and the primary and the secondary winding. The charge transfer from the primary to the secondary winding is entirely and purely through electromagnetic induction. The various transformer tapping voltages are mentioned for an input of 200 volts and the output of 200 volts. There are different tappings at 100 volts, 140 volts, 200 volts, etc. There are relays, relay 1, relay 2, relay 3, which switch on and off depending on whether the comparator has shown a requirement of a step up outside voltage or step down output voltage. Here the output is 280 volts, the input is 280 volts, sorry, and the output is 250 volts, because if the input goes as high as 240 volts, then the comparator will trigger the transformer's step down circuit and the output relay will connect it to the circuit, which reduces the voltage to 250 volts. This is how it does it. And conversely, when the input voltage is low at 130 volts, now the work of the stabilizer is to step up the voltage. So the transformer's step up circuit is activated as a result of the comparative circuit, and then the output of the transformer, which gives a step up of voltage, is activated, and 130 volts input is converted to 180 volts output from the stabilizer. This is how it works. So here is a table which shows the input voltage range, output voltage range, and what is the operational mode. Boost means step up, pass through means it is neither stepping up or stepping down, and buck would mean that it is stepping down. In the Godrej stabilizer, black color wire is neutral, yellow is the output, orange is tapping, and white is also a tapping of different step up and step down circuits. 9 volt to 18 volts. This voltage is required for the stabilizer PCB operation. So black is neutral, and between black and brown wires we get 9 volts, between black and red wire we get 18 volts, which will indicate that the transformer is in a healthy condition to supply the required voltage for PCB operation. Check the transformer tapings first to the last pin. The transformer is okay and the main card is the problem. If voltage is coming to 20 volts everywhere, replace the main card. Check the display wire whether it is loose, connections are loose, or whether there is some rusting. We can check the display card if the wires are not loose and still we get no display. There is also a glass fuse in the stabilizer. If the fuse is blown out, we can check and change the main fuse. Check the output terminal for loose connection either at the phase or neutral side. We would easily know by checking the wires which are connected to the output core. There is a time delay in the stabilizer. For restarting the stabilizer after it is shut down, it takes 180 seconds. This is to avoid the restarting of the compressor within 2 minutes of shutdown. Smart time delay of 3 minutes or 180 seconds, it's come into play. Because after any shutdown, the compressor rests for at least 3 minutes before it starts again. There are starting time delay for stabilizers after 5 minutes also. Here, as soon as the stabilizer starts, the compressor would start, because the 180 seconds of the compressor start delay is already within the 5-minute restart of the stabilizer. Low voltage cutoff and high voltage cutoff will give errors on the display as LC and HC. Whenever the input voltage goes beyond the input range, that is below 130 volts, then there is a low voltage cutoff, and the output input range goes above 280 volts, then also there is a high voltage protection cutoff within the stabilizer. It will show either HC for high voltage or LC for low voltage cutoff. The next thing is we have to check the power cord for proper operation, or whether there is any loose contact in the power cord, or whether some wires have been damaged inside. How to check it? We check open or short of the visual inspection, whether there is any visual damage to the insulation of the wires, or whether there is any rat bite. Then we check the neutral terminal to the neutral wire, the phase terminal to the end of the phase wire, and then the earth terminal to end of the earth wire. We also check whether there is any continuity between phase terminal and neutral wire, neutral terminal and phase wire, vice versa, and also whether any of these wires is internally connected to the. For visual inspection, if any kind of physical damage is there to the insulation of the wires, we have to change the power cord immediately. Otherwise, it can result in an electrical short circuit. This is how we test the power cord, all the 3 terminals vis-a-vis all the 3 wires.
इस वीडियो में हम देखेंगे पावर कॉर्ड कैसे चेक की जाए। पावर कॉर्ड को चेक करने के लिए हम 2 तरीके इस्तेमाल करेंगे। पहला है कंटिन्यूटी मेथड और दूसरा है क्रॉस कंटिन्यूटी मेथड। कंटिन्यूटी मेथड के लिए पहले अपने मल्टीमीटर को कंटिन्यूटी मोड पे लाएं। पावर कॉर्ड के जो प्लग टॉप है, उस प्लग टॉप के हर पिन के साथ रिस्पेक्टिव वायर की हम कंटिन्यूटी चेक करेंगे। अगर कोई प्रॉब्लम रहा तो यहाँ कंटिन्यूटी नहीं दिखाएगी और इसका मतलब है कि हमारा पावर कॉर्ड ख़राब है। क्रॉस कंटिन्यूटी मेथड में हम हर एक प्लग टॉप की पिन का दूसरे वायर्स के साथ कंटिन्यूटी चेक करेंगे। अगर कोई प्रॉब्लम है यहाँ पे तो कंटिन्यूटी दिखाएगा, इसका मतलब है कि वो वायर एक दूसरे के साथ शॉर्ट हो रही है और पावर कॉर्ड खराब है।
So this is how we check the continuity between the 3 points and the 3 end of wires.
इस
Checking the main fuse connectivity is required because there is a 5 ampere main fuse in the circuit, and if that fuse blows there will be no power input to the machine. This is how we do it as per this diagram. In HDG model, what we have to do is we have to connect it as it is shown in this diagram. We have to connect with the multimeter and then we have to check the input voltage. In the main PCB of HDG model, there is an 8-pin connector. In that connector, 230 volt AC would be shown coming in gray color wire. If not, then the main PCB is defective because the 230 volt, if it is not coming from the gray color wire, that means the PCB is defective. That gray color wire is the compressor output from the main PCB as shown in this diagram. And in the main PCB, the input wire is black is neutral and red is phase. Between the black and red wire, we get input 230 volts from the power cord to the PCB. And the same black wire and the gray wire, we should get 230 volts output going to the transformer, going to the compressor. Then here we are checking between the black and red wire in pin 5. We should get 12 volt DC. Same thing, door switch, black and red wire, we should get 4.9 or 5 volt DC as shown here in this diagram. That is how we should connect the multimeter and check. The first thing is LED connector at the main PCB, and then the door switch. Both of these we will check if we are not finding any light which is coming inside the machine. So these are the various checks that we can do to ensure or to diagnose why the power is not inputting inside the DC refrigerator. Thank you very much. See you later with another diagnosis.